Hello everyone, welcome to this video. In today's session, we will perform the experiment on chopper fed DC series motor speed control characteristics using VSoft DC drive trainer kit. This experiment shows uh, how the motor speed varies with the duty cycle of the chopper. The objective of this experiment is to study the speed control characteristics of a DC series motor using a DC chopper and to observe how output voltage and speed change with different duty cycles. Now let us understand first what are the equipments which are used for this experiment. Here we have a VSoft DC chopper fed drive trainer kit. We have a DC series motor. This DC series motor has a rated voltage of 220 volt. Rated current is 4 ampere. Rated power is 1 HP and the speed is 1500 rpm. We have a different patch cords. We have a tachometer which is used to sense the speed in rpm. So this is all about when we have a DSO in order to understand the pulse width modulations, right? Now understand how is this kit. This DC chopper fed drive trainer kit has two sections. One is the input section and another is the drive section. In the input section you can see there is a DC voltmeter which appears which shows the input DC voltage. We have a DC input terminals, we have a DC output on off switch, and the other section of the kit is a drive section. In the drive section you can see there is a DC current and voltmeter which shows the output voltage and current across the chopper. There is an RPM meter. Here is a schematic diagram showing input voltage, load voltage and the motor terminals and the chopper switch. Alright, here is a switch given for the motor interface. We have a speed control knob, right? So this is all about the kit. Now let us do the connections. Okay, so let us do the connections first of all. Now first connect the DC input supply across the DC input terminals from the input sections. Make sure that positive is connected to the positive terminal and negative to the negative. Then next connect the chopper terminals, that is V input, from the input section. Alright, then do the connections in order that the motor's reading can be interfaced by this multimeter which is displayed here also. Now you can see this motor is connected to this switch, to this knob. We can connect the DSO. Alright, so here we end with the connections. All the connections are now complete. So before powering on, recheck the polarity and wiring. Now first of all understand the concept. What is a chopper? Chopper is a power electronic device which converts fixed DC into variable DC. And here we have a DC series motor. What is the property of DC series motor? A series motor is, here the field and armature winding are already connected in series with each other and the speed is directly proportional to the voltage. Alright, so when the chopper switch is on, the full voltage is applied across to the is applied to the motor, and when it is off, voltage becomes 0. Right? So now we will turn on the. Right, now we have turn on the switch. Now the rating of the motor, as it is 220 volt. Now we have given the voltage is around 80 volt. Now let us take the first reading. Now I will turn on this MCB. Now we have given the supply voltage is around 80 volt to the thermostat. Here the voltage is reflected as 72 volt. This current shows the chopper's armature current, that is 0.5, and this is the voltage, that is 12.7. The motor is running at the speed. Now let us see that if I want to change the speed, if I change this knob, or with the help of this knob we are changing the duty cycle. Let us take an example. First reading with the help of the tachometer. Now here the speed is around 230. Now see the first reading. Here the speed is 230 rpm. Understand the sample calculation. For example, here the input voltage is, we have seen the input voltage is 73, which is a constant, and the output voltage, that is a measured value. This measured value is 15.1, and the armature current you can see is 0.59. So with the help of this formula, this is the percentage duty cycle is equal to, this is V output upon V input multiplied by 100. So here the V output voltage, that is the measured value, is 15.1 and the input is 73. If we multiply it by 100, we will get this value around 22.9% something, that is nothing but which is equal to 23%. So this is 23% duty cycle. So this is our 23% duty cycle. The output voltage was 15.1. So now at 23% duty cycle, the speed is 230 rpm. Now if I go on changing the duty cycle again, now likewise you can take different sets of readings, like one is 23, then you go for 30, then you go for 35, then 40, 45. Likewise different sets of readings can be calculated. So as you go on changing the duty cycle, if I go on changing the duty cycle increases, the output voltage, you can see the output voltage is increasing. Now for example, the second is 16.3. So as you go on changing the duty cycle, you go on increasing the duty cycle, the output voltage will increase and the current will also increase and the speed will also increase. Now here also you can see in the DSO, here you can see we have given a fixed DC voltage, that is 72 volt. Even though we are changing the duty cycle, there is no change in the DC input voltage. So this is how the principle is. The chopper converts fixed DC into variable DC. Here you can see that we have a variable DC. You can see this output. Here it is variable DC, right? Likewise, we can plot the graph of duty cycle versus speed. So this graph interprets that as the duty cycle increases, the average voltage increases, and therefore the speed of the DC series motor rises almost linearly. Okay. As a result, the conclusion here, we conclude the experiment as the demonstration of the speed of the DC series motor can be effectively controlled using a PWM based DC chopper. Higher duty cycle gives higher average voltage and therefore higher speed. Thank you for watching this video. If you found it helpful, please like, share and subscribe to this channel.